Hello, Math 1 students. The first I can statement for Unit 1 was 1.I, which is I can simplify by multiplying powers, right, that have the same base. Okay, so we're actually going to go with this one, we're going to go back to the basics, and we're going to talk about what an exponent really does. And we're first going to start with anytime we deal with exponents, we have what we call a base, and we raise that base to an exponent. And that exponent, another word for it, you'll see, is the word power. So with this, what that exponent does is it basically tells us how many times we multiply the base by itself. Okay? So if I had like 4 to the third power, right, that exponent 3 tells me to multiply the base of 4 by itself 3 times. And now 4 times 4 is 16. 16 times 4 is 64. So 4 to the third is equivalent to 64. Now what happens is when we talk about this multiplying powers that have the same base, all right, we use what we call this property. It's called a product of power property to simplify these expressions. So let's look at what we have here. If we took and expanded each of these expressions, right, and we rewrote it using one base and one exponent, what would it look like? Okay, so if I expand x to the fifth, that's the same as x, and that's going to be 5 times 1x, right? How could I basically rewrite this using exponents? Well, my base is going to be x, and I know if I have x multiplied by itself 6 times, it's going to be rewritten as x to the 6th. Now the next one, this gives me x times x times x. This, right, gives me x times x times x times x. So how many total x's do I see here? I now see 7. So that can be rewritten as x to the 7th. Now the next one, we could rewrite that as x times x. We can rewrite this one as x times x times x. And right away when I look, how can I rewrite that using one exponent? If I'm multiplying x by itself 5 times, that would be x to the 5th power, right? The next one, this is 4x's multiplied. This is 2 for a total of how many x's? That can be rewritten as x to the 6th. Now, for this one, I can rewrite this as x times x, then y times y times y, then x times x times x, and then multiply y by itself 4 times. So if I were to rewrite this, remember, multiplication's commutative. If I were to take these 2x's and 3x's, I could rewrite this problem as 5x's multiplied together times, take the y's, and that would be 7y's multiplied together, which means I could rewrite this as x to the 5th, y to the 7th. Okay, we always like to write it in alphabetical order. Well, if I gave you a problem such as x to the 153 times x to the 2000, right? Would you want to expand these out and rewrite them like you normally would? No, you'd want to figure out a shortcut. So what is the potential shortcut? Well, if I look here, how could I go from x to the 5th times x to x to the 6th? How could I go from x to the 3rd times x to the 4th to x to the 7th? Well, if you notice, the exponent on that x is actually 1. So if I take the 5 and 1 and add them together, do I get x to the 6th? Can I do x to the 3 plus 4, which would give me x to the 7th? Would x to the 2 plus 3 give me x to the 5th? Yes. So the rule we could derive from this situation is the fact that if I'm multiplying same bases, notice my base of x, my base of x, what I could go ahead and do is I can shorten it by just adding the exponents. So right away with this first one, all I'm going to do is multiply same bases by adding the exponents. So this would be x to the 22nd power. Here, I would have x to the 8th plus 9, which would be x to the 17th. Okay, now this one, remember, I'm going to multiply the x's together, then I'm going to multiply the y's together. When I go to multiply the x's together, I'm going to do x to the 3 plus 5 times y to the 4 plus 9, and that would give me x to the 8th, y to the 13th. Oops. So let me rewrite that here. And we are done. Do me a favor, pause the video and try the next one on your own real quick. So when you look at this one, I'm going to multiply 6 and 4 to get 24. Now, x to the 8th times x to the 9th. When I add those exponents, I would get x to the 17th. Then y to the 5th times y to the 4th. When I add those together, 5 plus 4 is 9. And z to the 3rd times z to the 8th, 3 plus 8 would give me z to the 11th power. And I am done. So the shortcut using the power of product of a power property is just when you multiply same bases, we add the exponents. Okay, so letter A here, 3 to the 4th. If we had to simplify and evaluate, this is already simplified, but if we had to evaluate, think of this as 3 times 3 times 3 times 3, which gives you 9 times 3 is 27 times 3 would be 81. This example, multiply same bases. I'm going to write it as one single base of 2, and then I'm going to add my exponents. So when I simplify it, I would get 2 to the 5th power. Now, if I evaluate that, I can either use the calculator, right? Or 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 would be 32. And that's what I would get if I simplify that. Letter C, 3 to the 1st power times 3 to the 3rd. What do I do with the exponents? I'm going to add them to get 3 to the 4th power. Now, I could go right away back to A and say that 3 to the 4th power, we can evaluate it to get 81. Okay, letter D. I'm going to simplify this by adding the exponents to get 5 to the 5th power. So if I had to evaluate 5 to the 5th power, I'd go to my calculator, I'd hit 5, the caret key, and 5, hit enter, and that would give me 3,125. Now, negative 3 to the 3rd power. Remember, this is negative 3 times negative 3 times negative 3. Now, right away, negative 3 times negative 3 is positive 9. And positive 9 times negative 3 would give me negative 27. Now, when I put that in the calculator, I have to put negative 3 in parentheses, raised to the 3rd power, and right away, I would get negative 27. And the last one, if I do negative 2 to the 4th, negative 2 times negative 2 times negative 2 times negative 2, that's going to give me 4 times negative 2 is negative 8 times negative 2 would be positive 16. Okay, so when we evaluate, you have to know how to break those down. So right away, we have some, expressions to simplify here. I would encourage you to try each problem on your own and then come back and check your answer. Okay, so the first one, x to the 14th times x to the 8th. I know I'm going to add the exponents to get x to the 22nd power. Letter B, again, multiply same basis. When I multiply the a's together, I add the exponents 5 and 8. And then the b's would be 7 plus 9. So that would be a to the 13th times b to the 16th. Now the next one, before I go and do this, I have to multiply what we call the coefficients, right? Negative 3 times 8 is negative 24. Now when I multiply the bases of x, I'm going to go ahead and add those exponents. I'm going to get negative 24 x to the 13th. The next one, 8 times 7 is 56. X to the 3 plus 2 would be 56x to the 5th power. Letter E, negative 4 times negative 6 is 24. When I multiply the x's, add the exponents, 3 and 4 would give me 7. Y to the 5th times y to the 3rd would give me y to the 8th. Okay? A to the 8th times a would give me a to the 8 plus 1. Remember, the exponent on a is 1. Then b to the 7 plus 10. So my final answer would be a to the 9th, b to the 17th. Okay? Then, negative 2 times 7 would give me negative 14. R to the 4th times r would give me r to the 5th. S to the 3rd times s to the 2nd would be s to the 5th. And then t to the 6th times t to the 4th, 6 plus 4 would give me t to the 10th. And I am done. Here, 5 times 6 would be 30. X to the 3rd times x to the 7th is x to the 10th. And then y to the 2 plus 8 would give me y to the 10th. And we are done. Then finally, the last one. Multiply the coefficients together. That would give you positive 56. X to the 4th times x to the 2nd is x to the 6th. Then y to the 1st times y to the 3rd would be y to the 4th. Okay? So, following this is another worksheet that you guys can do, all right, and allow you to check your answers. Okay? So, please finish that worksheet and let us know if you have questions.